Hello. Let's quickly do this question. This is the sub of 2021 physical science paper 1. We are going to do the Newton's laws only for now. An 8 kg block on a rough horizontal surface is connected to 2 kg block by a light inextensible string passing over a frictionless pulley as shown below. The 8 kg block moves at constant speed. So what we know is that when they say constant speed, which means initial velocity is equal to final velocity, that is, there is no change in velocity, meaning that the acceleration is 0 meters per square second. This also implies that F net is equal to 0 newtons when pulled by 29.6 newtons horizontal force to the right. The frictional force acting on 80 kg block is 10. So we also have the frictional force on 8 kg block, which is 10. So what is important is to draw the free body diagram, but let's just go straight to the questions. State Newton's second law in words. Newton's second law states that when the net force acts on an object, the object will accelerate in the direction of the net force with acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. Directly proportional to the net force and acceleration is inversely proportional to the mass of an object, meaning that when the mass is going up, therefore acceleration is decreasing. When the net force is increasing, so does the acceleration. Now let's go to the same question. Draw a labeled free body diagram. We're going to draw the free body diagram for both. Okay, so let's start with this one. This one is very easy. We have this string, which means we have the upward force, which is a tension. Then we have Fg. So this one is Fg. Then here we have this tension in that direction. Then we have this force applied. We have the normal force, which always acts parallel or perpendicular, to the surface. Then we have what? Fg. So let's draw the free body diagram. Let's start with 2 kg. It's 2 kg and what? 2 kg and 8 kg. Let's start with 2 kg. 2.2. For 2 kg, we have the free body diagram, which is a tension only. That is a tension here, tension force and Fg. There is no normal force because it is not touching what? The surface. Then we have 8 kg block. 8 kg block. There is a tension there. There is a what? A normal force. There is a normal force. There is the weight. We also have the force applied. There is a friction. The object is moving in this direction. Therefore, the friction is opposing the motion of an object. So we have Fk here. Then this is 5 marks. We must have 5 forces. 1, 2, 3, 4, 5. And as forces is, before you calculate, they must be vertical and horizontal. There must be perpendicular forces and parallel forces only. Okay, if there is a slanted force like this one, let's say we have this force slanted like that, which means we are going to have a tension which is Ty and another component with it, which is Tx. Okay, now let's go to the following question. The following question says, where is it? Calculate the tension in the string. So since the question says calculate the tension, we are going to start with the simplest free body diagram. If you can look here, this one is very simple, which means let's try here. So that is 2.3. So F net is equal to MA. But remember that in the statement there is a constant speed, therefore F net is equal to 0 because the acceleration there is equal to 0. The forces are balanced, so F net is equal to 0 because the forces are balanced. Since it is accelerating in this direction, okay, let's go to the diagram. This one is accelerating in this direction, therefore this one is accelerating upwards, or is moving upwards because the acceleration is equal to 0, is moving upwards. So it is moving in this direction, motion I, therefore the motion for this one will be upwards. Therefore this one must be positive, then label negative. So we have a tension which is positive minus Fg, which is equal to 0. So tension minus this one is equal to mg is equal to 0. So the mass for this one is 2. So we have 2 times 9,8, which is equal to 0. Then we press calculator, then we get the tension, which is equal to, if you transpose, which is 19,60 newtons. Then let's go to another question quickly. Another question says the 29,6 newtons horizontal force is now increased to 50, which means the force applied now is 50, meaning that ayisazi uhamba nge-constant speed, it will accelerate because the force applied is increased. Okay, it will accelerate in this direction. So they say 2.4, apply Newton's second law into each block and calculate the magnitude of acceleration of 8 kg block, then 5 marks law. So we will try with this one. The tension does not change the whole. Okay, that is 2.4.1. 2.4.1. Okay, it's 2.4.1. Now we must write this one, F net is equal to MA. So if you can look at marks here, we have 5 marks, okay, which means we're going to have 2 equations, maybe that is tension and acceleration. There are 2 unknowns, so we're going to have 2 equations. Okay, now if we can look here, we have tension and Fg, which means we have positive tension minus Fg, which is equal to MA, right? Then let's continue. The tension is the same throughout. The tension is the same throughout. So the tension, no, it's not the same. It's not the same. So we have tension minus this one is equal to mg. The mass for this one is 2, then times 9,8, which is equal to the acceleration, or the mass is 2, but we do not know the acceleration. So we have t minus 19,6, which is equal to 2a. This is the first equation, sorry. Now let's go to another object. Let's use this one now. This one is positive, this one is negative, and this one is negative. So we get F net there. So for 8 kg block, we have that free body diagram. It has a force applied. It has what? The normal force. It has the tension and the friction. Then we have Fg. So this one must be positive, this one is negative, this one is negative. So F net is equal to MA. But this one is positive. Okay, FA minus tension minus FK, which is equal to MA. So the force applied now is 50. We don't know the tension, but the friction for this one was given before. Let's go back to the statement. The frictional force for 8 kg block is 10. So we have the friction of 10 newtons, which is equal to the mass is 8A. So if we press calculator here, 50 minus 10, that is 40. So we have T minus 40, which is equal to 8A. Then we have equation 2. Then we can just bring this one next to this one. So we have T minus 19,6, which is equal to 2A. That was equation 1. So equation 1 plus equation 2. Equation 1 plus equation 2. Then T minus T is 0. Then minus 40. Oh, it's supposed to be positive 40 here. 40 minus 10. So we press calculator there. So we get positive 20 here. 20,4, which is equal to 8 plus 2, that is 10. Then we divide by 10 both sides. Then we get acceleration, which is equal to, let's divide by 10 there, which is 2,04 meters per square second. Let's go back and check the question. The question was calculate the magnitude of the acceleration. The following one, calculate the tension. So we are going to continue. We're going to take one equation there. So for tension, we can take any equation. Let me just take this one. I have minus T plus 40, which is equal to 8A. Then in place of A, I will just substitute minus T plus 40 is equal to 8 times 2,04. Then I will transpose and press calculator. Then we get T. Then we get minus 23,68. Then divide by negative. Then T is 23,68 newtons. Then this question is answered. That was the last question, tension on the string. Now if we can look, the tension before was 19, but the tension, now that the force applied is increased, the tension also increases. The tension increases as the force applied increased there. So thank you. Don't forget to subscribe and follow me on Facebook, Lukhona M Sciences. Thank you.